Good morning. In this video, I am going to explain the introduction of a linear programming problem under my paper Discrete Structure and Optimization Technique. Introduction to linear programming problem. Linear programming problem can be written as LPP model. Linear programming problem has nothing to do with computer programming. The use of word programming means choosing a course of action. Linear programming involves choosing a course of action when the mathematical model of a problem contains only the linear functions. Linear programming will act only for the problems which has an linear functions. That is, the power or the degree of an variable should be 1 in the particular equation. Then only we can use this problem by using a linear programming model. Linear programming problem LPP. The maximization or a minimization of some quantity is the objective in all linear programming problem. The main aim of this LPP model is to maximize the profit and minimize the loss. So we are having some objective function. That objective function may be maximum or minimum according to the given set of problem. All the linear programming problem have the constraints that limit the degree to which the objective can be pursued. That constraints may be of a greater than or is equal to, or less than or is equal to, or sometimes equal to. These inequalities are included in that constraints. A feasible solution satisfies all the problem's constraints. Feasible solution may be maximum or minimum. Sometimes it may be an unbounded solution too. An optimal solution is a feasible solution that results in the largest possible objective function value when the maximizing or smallest when minimizing. Graphical solution method can be used to solve a linear programming problem with two variables. There are so many methods to solve a linear programming problem. Of those, we are having a graphical method, simplex method, dual simplex method, big gum method. So many methods are there. I have posted in my videos as graphical method. Problem formulation. If both the objective functions and the constraints are linear, then the problem is referred to as a linear programming problem. If both the maximization or minimization and the subject to the constraints are linear, then only the problem is said to be a linear programming problem. Linear functions are functions in which each variable appears in a separate term raised to the first power and is multiplied by a constant which could be a zero. Linear constraints are a linear function that are restricted to be less than or equal to or greater than or equal to a constant. For example, the equation will be of the form of 5x plus 3y greater than or is equal to 10. Sometimes 5x plus 3y less than or is equal to 80. So this inequality tells about whether the profit is maximum or minimum, and the objective function tells about the maximization or minimization of the problem. Problem formulation or modeling is the process of translating a verbal statement of a problem into a mathematical statement. That is, the verbal statement is converted into a mathematical statement by using the constraints. Formulating models is an art that can only be mastered with the practice and experience. Every LPP problem has some unique features, but most problems also have a common features. General guidelines for LPP model are illustrated below. Guidelines for model formulation. Understand the problem thoroughly. Describe the objective function. Describe each constraints. Define the decision variable. In sometimes there will be a 3 decision variables. For example, if we study about a case study problem of a diet problem, we will have a 3 kind of a decision variables. That is protein, fat and carbohydrates. According to the given problem, we can change our decision variable. Write the objective terms of a decision variable. Write the constraints in terms of a decision variables so that we can formulate it as an LPP model. My simple maximization problem is given. Mathematical formulation will look like an objective function is maximize or minimize is at c1 x1 plus c2 x2. That is nothing but the constant into x, that is x is decision variable, and x2 x1 x2 is the decision variable. Subject to the constraints may be maximum availability or minimum commitment or equality. It is considered by the following three inequalities equations, and my finally non-negative restriction is nothing but x1 x2 should be greater than or is equal to 0. That is non-negative means positive. Therefore, I have switched to greater than or is equal to 0 value. So this is how we have to formulate the LPP model before solving the problem for a statement problem. Thank you for watching this video. Thank you.